Today's lesson will cover the final two methods of communicating enthalpy changes. Recall from the last lesson that there are four ways to communicate enthalpy changes. The third way to communicate enthalpy changes is by including energy as a term in a balanced equation. For endothermic reactions, the energy term is included on the reactant side. In exothermic reactions, the energy term is included on the product side. Recall from the last lesson that if the change of enthalpy for a reaction is positive, the reaction is endothermic, and if the change of enthalpy for a reaction is negative, the reaction is exothermic. Using this information, you should be able to determine which side of a chemical reaction equation to write the energy term on. During a chemical reaction, observed energy changes are due to changes in chemical potential energy. This energy is a stored form of energy that is held in the bonds between atoms. As bonds break and reform, changes in potential energy occur. Evidence of a change in enthalpy of a chemical system is provided by a temperature change of the surroundings. A chemical potential energy diagram shows the potential energy of both the reactants and products of a chemical reaction. The difference is the enthalpy change. The vertical axis represents the potential energy. The reactants are written on the left and the products on the right. The horizontal axis is also labeled with reaction coordinate or reaction progress. In an exothermic reaction, the chemical potential energy of the products is lower than that of the reactants. This is shown by a decrease on the diagram. Conversely, endothermic reactions result in an increase in chemical potential energy. This is shown by an increase on the diagram. These diagrams relate the potential energy diagrams to calorimetry. Note that the released energy in the exothermic reactions goes towards heating up the surroundings. In endothermic reactions, the energy that goes towards making higher energy bonds comes from the surroundings and results in a cooling of the water in the calorimeter. These two diagrams from your textbook show how you should be drawing your potential energy diagrams. Notice how the actual chemical symbols of the reactants are written on the left side and the products are written on the right side. The amount of energy released or gained from the reaction is indicated on the potential energy diagram. Be sure to include units. This diagram from a textbook is a good summary of how exothermic reactions and endothermic reactions are presented in each of the four ways of communicating enthalpy changes. Exothermic reactions will have a negative sign for the change of enthalpy. The energy term will be written as a product, and the chemical potential energy diagram will show a decrease in energy. Endothermic reactions will have a positive sign for the change of enthalpy. The energy term will be written as a reactant, and the chemical potential energy diagram will show an increase in energy. You should now have an understanding of the four methods used to communicate enthalpy. We will be going over several examples in class.